Hello everyone. I hope the stream is live now. So it look like so it looks like the stream is live. So let's start today's class, which is casting important questions for GATE. So let's start the class. So once again, hello everyone and welcome to Unacademy classes. My name is Abhishek Mishra, and in this class I will be going through some important questions from the casting topic in manufacturing subject for GATE exam. So we will be looking into some of the very good questions that will not only make your concept stronger, but that will also help you revise the formulas that you have learned, and ultimately these things will going to help you to prepare better or to be better prepared for your GATE examination. And during our class, as you can just get an idea if you have attended my previous classes, we will not be just solving a question and moving just forward to the next question, but we will be analyzing a question. We will be discussing tips and tricks so that you can do a question with least possibility of making error and in a fastest possible way. So that will be taken care of, and I will also be making you aware of the potential errors which you can make or which a student can make, so that you can just always know what type of mistakes one can do to just avoid them. So these are the things that you can expect in my classes, and we will have a very nice and calm discussion. And again, if you are watching the class live, I will be interacting with you a lot, which will, I think, help you understand topics better. And live classes are the way to just study online, because the interaction here can clear your doubt on the spot and you can just move forward to the next topic without wasting your time just getting the topic or concept correct. So again, to start this class, let's introduce or talk a little bit about me. So I have secured All India rank of 662 in GATE 2020. I have completed my MTech in 2019 from IIT BHU Varanasi. 2 years mechanical engineering teaching experience, and interest of mine are here shown in the screen: photo editing, video editing, cricket, football, and I like all sorts of games. So these are the some of my interest. And as you can see from this information about me, I have prepared for GATE examination and I have also taught it. So I have accumulated over the year a lot of tips and tricks, a lot of important points that you should know, you should be aware of, to just be confident and score good marks in GATE examination. And again, this class will be very relaxing class, very calm class. Uh, we will not just be in a hurry. We will do a question properly, see it, and I will give you ample time if you are watching it live to do the question also. So Unacademy app is free to download. So just go to your respective app store and download this app, and just check out its feature, what it offers. And since this app is free to download, so you should just check it out. There is no harm in checking out a free app. And as you can see in the screen, this app has all the features that you need, all the things that you need if you are preparing online. And name one thing that you require for your online preparation, and this app has got it covered. So that will be the discussion about the app. Now we will move forward and discuss about Unacademy subscription and what you will get. So Unacademy subscription, first of all, Unacademy is asking very reasonable price, which I will be showing you, and I will also be giving you a very special code which you can enter to get 10% discount when you are going to subscribe to Unacademy. So that special discount I will be sharing just in a few minutes. So when you subscribe to Unacademy, you will be getting daily live classes, live tests and quizzes, structured courses, unlimited access, and what these features are written in the screen. and you can always go to Unacademy's website or app and check out what Unacademy subscription is offering. And when you are subscribing to Unacademy, you are going to get your money's worth from day one, because daily live classes will be held, which you can attend, which you can ask your doubts, answer polls in the classes, and you can do all this while class is going on. So you will be getting your money's worth from the first day or the moment itself, because day in day out this quality live classes by the top educators will be occurring. So you can just attend one of the classes and start your preparation, and there are live tests and quizzes for you to evaluate your preparation. And a very important thing about this test is that you will be getting a detailed analysis on your performance, which is a must, because this analysis will give you the information that you need to improve, because they will provide you what are the areas in which you are lacking, in which areas you need to improve your speed. So that are the things that you need to be analyzing, because you need to be properly prepared in each and every areas that can give you marks. So this will be make sure by Unacademy's test series analysis. So again, a very good feature of Unacademy. So subscribe if you want to just get benefit of this feature. And structured courses are there. So what the structured courses means is that your courses are in line with syllabus, so that is fine, but the courses are also arranged in such a manner which is for progressive study. That is, they will help you study in the manner that is just logical, and that is just that will just create a rhythm, because you have to prepare for GATE for a large number of days, and throughout each and during each day you have to be well motivated, well energized, and this will be taken care by the structured courses. So again, very nice feature, and this is not there in YouTube. In YouTube you have to you will find the courses in a scattered manner, which is obviously not recommended when you are preparing online. And also I would like to inform you that for daily life classes, the level of interaction offered by the Unacademy's website is far better than what we see here on YouTube. Because Unacademy website, we can have a lot of tools like answering polls, asking your doubts, which you can just provide the educator right in his or her screen, because here on YouTube it is having difficulty to see your comments. We have to use a cell phone or things like that. So again, nice features by Unacademy, and a lot of tools provided to educators to teach, which is obviously a plus. And through that they can express your themselves better. So I think that is again a plus. And unlimited access of content will be provided. So one subscription gets you access to all the live and recorded classes. So this is again a very important thing, because you now have a lot of content. When you subscribe, you just have to select a content and start your preparation. So as I have discussed before, there are top educators, and these educators, what is the benefit of learning with these educators is that they will not only give you best possible education, but they will also provide you their experiences, their tips, tricks, like I am giving you in this very class. And this will make you just prepare in a manner which is very efficient than if you are preparing by some other means which are not with the top educators. And multiple educators are there for a single subject. So another nice option for you to just choose from, choose the educator which resonates or who resonates with you most, and then attend his or her class. And here are the subscription prices for Unacademy, and as you can see, the subscription prices here are very reasonable. Just compare them with. So Banu Ranjan, hi. So let me just first of all discuss the subscription prices, then we will move to the questions. So the subscription prices are very reasonable as compared to the rest of the competition and some traditional offline classes. And this prices also include the test series, which obviously cost thousands of rupees on their own. And if you want to get this subscription in least possible price, then enter the code that is shown on the left side of your screen, ABHIMI. And again, no cost EMI option is available on 6 months and above subscription, and the best subscription to choose from is 12, 18 or 24 months, because they are offering a lot of discounts. But if you are not sure, you can always go with 1 month subscription to try what the Unacademy subscription is offering and if it is resonating with you or not. And these are the subscription prices for plus subscription, which is a classroom type experience. And if you need more assistance, then you can also go with Iconic, where you will be getting personal coach, personalized test series. Again, same code can be used here, and these are the least possible price after applying this code, which you can just get the Unacademy subscription for. So again, here are the benefits of Plus and Iconic, and this is the final slide. After this, we will start this class. And again, I would like to just point it out that the code in the left side of the screen is ABHIMI. This is the code that you have to write down to get the 10% extra discount. So again, very good thing if you want to do savings and who don't like savings. So let's just start the class. And before starting this class, I would like to inform that I will be taking 8 p.m. today class at Unacademy's website or Unacademy's app. You can find me there. We will have a only 1 hour class, so a nice short discussion we will be having there. So if you want to attend, then you can attend there, and you can also get to know what type of subscription, what type of just interface Unacademy's website is having, and the class will be free for you to attend. So again, I would just like to inform you that. So here is the first question. So since the topic of today's class is casting, so let's see here. The first question is just asking us that what are the steps followed in a typical casting process. So again, Banuranjan, good afternoon. You are watching this class live. So what will be the answer of this question? We have molding, pattern making, melting and pouring, core making, testing, inspection, fettling. So in which, so this question I am just giving you starting with, because this will just warm you up. B. So Banuranjan has given the answer B. So let's see what B is. First is molding, means you are going to prepare your mold sand box, and then you are saying pattern making, and then it is 4, that is core making, then 3 melting and pouring, testing and inspection after that, then fettling. So is pattern making going to come before molding or not? Is pattern making going to come before molding or not? So obviously you have to prepare your cope and drag first, and then you have to make the pattern. And so this can be a little bit confusing, but let me give you a basic idea about casting by opening one of my slides, which is which will give you a very nice example there. So let me just do that. So let's just see a real life example. By looking at this image, you can get a better idea of what casting process, in what steps we do. Obviously you must know this because you have prepared in casting, but it is better to just see this to get a good look. So first of all, this is the first step in our casting process. Pattern is set in drag with gating system. So can you see here the drag, that is obviously the bottom part of your mold box, and inside this drag you have just made the or just put the pattern there along with the gating system, which you can see here. This is your gating system, this is your pattern. So after that, what you will do is you will just put the sand, place the sand here, and you will do hand packing around the sand to make the cavity. You are doing this and you are covering the pattern, or just putting the sand around the pattern and also around the gating system. And after that you are going to do ramming. So why ramming is done? Ramming is done to give dimensional stability to the cavity, because when you are going to or after you have just removed the pattern, you want your cavity to be in well shape and size. Don't get just don't be unstable, so you can just do your or continue your casting process. So for dimensional stability, ramming is done. And after ramming, you are going to strike off the drag. So you have to strike off the excess sand by just a striking bar or striking rod. So this is just done so that you can close your drag and cope box properly. Excess sand is of no use, so we are just doing that. And after this, you can see your drag is ready for the cope. So you have to prepare now cope. And again, in this image, in this very image, you can see your pattern, which we will remove, and also the gating system, which will also remove to get our final mold cavities. So this is the cope now. Again, we are putting the pattern in the cope with the gating piece, and we have to repeat the process that we done for the drag. And ramming, again we will have to do this because we will also have to give dimensional stability to the cavity that is in the cope. And then we will do venting, which is done to give to make the gases escape, which will just occur when your molten metal will be poured inside the cavity. So if you are not doing that, then your final casting will become porous, which is obviously not desired, because after it has become porous, it will lose its strength, which obviously it not is the not our desire. And start of the pattern draw. So in this step, you can see the pattern is being drawn from the mold box, and we are carefully drawing it just to make sure that the cavity is well in shape, not get just broken off or change its shape. And pattern is completely drawn, and what left is the cavity. And again, you can see in the screen that the gating system is also the cavity of gating system is also made here, so you can see that. And now we are setting core, and core is used to create the hollow structures, so therefore we are setting it. And cope and drag is ready for closing now, so you can see have a proper nice look here. And core is still in the place. So if you are using core, then when we will see the final casting product, you will see there will be a internal hole or internal cavity in the object. So this core, just remember its shape and then compare where the hollow structure you are going to find. And again, we have clamped the mold so that it gets closed properly. And then you can see the pouring basin where we are going to pour the liquid metal. And now we are doing the pouring. And here is the final finished product, which we have prepared from the images or from the steps that we have followed. So here is the pump housing casting, and you can see the internal hollow structure here also that is made by the core. So that will be the steps of a casting process. And here what we were doing the questions is pattern going to make we are going to make pattern first or after this molding. So this can be a little bit tricky. I think pattern should be just prepared first, because we have to use that pattern in the molding box to create the cavities. But here in the options given, I don't think that we have a option where we can see pattern making then molding, that is two after one. So molding and pattern making can also be fine, because it can also means that we are preparing the set cope and drag, we are getting it ready, and after that we are putting inside the molding box the pattern to get the molding cavity. So you can just see the options, and B is going to be the correct one here. And I hope the rest of the options are clear. Melting and pouring, core making should be coming after your pattern making. Testing and inspection, fettling is just cleaning. So after you have obtained your final casting from the mold cavity, you will see that gating systems will be attached with the your primary casting. So you have to just remove that. You can remove that through vibrations, and just clean that, so that your final finished product is the one that you just desire, not the gating system and all that. So fettling is just cleaning. So that will be it for our first question, and I hope that is clear. And now we can move forward to the second question of ours for the day. So second question is a numerical question, which is just here stating that we have a rectangular plate of dimension 15 cross 24 25 cross 4, and all the things are given in centimeter, and we have to cast by sand cast mold, and total solidification time when mold constant is 195 6000 second per meter square. So what will be the answer here, Banuranjan? Again, if you are still watching, if you are following the class, then what will be the answer to this question? We have to find the total solidification time here in minutes, and we have been provided with this mold constant and the dimensions of the casting. So what will be the answer here? Again, you should take, I think, only under 1 minute to solve this question. Again, very not that difficult question. You have to just apply the solidification time formula. So right now I'm going to write the formula, then I'm going to do this, solve this properly after 30 seconds. Since this question is having a very nice thing that we have to just remember while doing our questions, is the unit. The units are given in centimeter for the casting, but the mold constant is given in second per meter square. So again, since this is an objective type question, so you can, if you make mistake, you can always see that. But for subjective type filling the blank question, you will not get this opportunity to just get this information that you have used correct unit or not. So always remember that you are checking the units before doing your solution, and when you are writing the answer, you should also do that. So Banuranjan, you have taken a lot of time. What will be the answer to this question? You should have solved this in under 1 minute. If you are not solving, then also it is okay, but you have to try to improve your performance going forward. So again, simply solidification time we have to calculate by dividing the volume by area and taking its square. So I just want the answer here so that we can, so calculation mistake, and you have to be, so that's why you have to solve a lot of questions so that this mistakes you can avoid in your final gate examination. So again, I have given ample amount of time. Now I am going to just solve the question here. So TS solidification time will be 195,600 into volume is just 15 cross 25 cross 4, and this we are going to convert it into centimeter because our volume is in centimeter and our dimensions of casting are in centimeter. So let's convert this into centimeter also. So meter square will just simply become 10 raised to the power 4 centimeter square, and area will be twice length into breadth plus breadth into height plus height into length. So what will be the answer here? Let's see. So Banuranjan is saying C as the answer. So Banuranjan, my answer is coming out as 6.4, which I think is also the one in the answer key. So that will be the correct answer. How you are going getting this 4.57? Please check out the, and I have not made this square here, so I have made this error. But in the calculation, I have calculated it just fine. I have just forgot to write this square in this screen, but the answer is coming out as 6.4. So what you have followed the same process, I hope, and you have converted this in respective units. Have you done this square or not? Have you done this square or not? So just check, take your time. I am giving you 1 more minute. So Banuranjan, I have checked it for you. You have not squared the V by A ratio. The V by A ratio is coming out as 1.4, and if you divide 6.4, that is the correct answer, with 1.4 you will be getting 4.6, which your answer was, wrong answer was. So again Banuranjan, I have also made this mistake during my time preparation, and that's why I always make sure that I am very careful in doing this question in calculating solidification time, because here the calculation is a little bit long, not long but just a tiny bit long, and that tiny bit long calculation can make us forget that we have to do V by A square. So you have to see this also, that if you are making the wrong answers, there is a option there in the, there is a option there for you to select and get the wrong answer, and therefore you have to be very careful, not just see the option and just be happy that you have found the answer, because options are there to trick you if you are doing the common mistakes. So here just make sure that every time you do this questions, make sure that you are doing the square. Just make sure from this point onwards. Now the next question is asking converging passage in sprue and runner of a gating system for feeding the liquid metal into the mold helps in. So we have a converging sprue, and why the converging sprue is there, we have to answer. So again I expect the answer here in just few seconds. You can just read it, take your time, take 30 seconds. So Sorendra D, C is the answer you are giving, and Banuranjan is also giving C answer. So that is the correct answer, C. We have to avoid the air aspiration effect, and therefore we are making this converging passage. And let me just show you one thing. So let me show you here the figure. Always make this from beginning mistake. So this is design of sprue, ideal design and actual design. So as you can see, the ideal design is parabola, which we get from the Bernoulli's equation, and the actual design is tapered cylinder, which we are using because we want less difficulty in manufacturing, and therefore tapered cylinder is also doing the job properly, and both of these are converging, and they are avoiding the air aspiration effect. So here what air aspiration effect is, you can see first of all in the first figure you can see the free falling liquid metal. So if liquid metal is just free falling without any passage, it will just take this shape, converging shape, that is the top portion will be having more area than the bottom portion, because the volumetric flow rate will be same, and velocity will be increased as we move towards the down, and therefore area needs to be reduced to just account for that increasing velocity. And if we are giving this straight passage, then there will be area where low pressure will be just created, and therefore in that low pressure the air from the outside will be just getting inside this passage and just mixing with the liquid metal, and therefore will make your final casting porous. So we are creating this tapered section to avoid this air aspiration effect. So again, just remember that ideal shape is parabola, but the actual shape that we are using is tapered cylinder because of the manufacturing difficulty. So let's just do the next question. So which of the following tool is used to remove the pattern from the mold? Again, options are given, and I am expecting the students who are watching to provide this answer also. So what will be the tool, name of the tool which is used to remove pattern from the mold in the casting process? So Banuranjan and Sorendra, if you are watching this live, select one of the answer, one of the options. B, draw spike. Sorendra has given the answer. Banuranjan, can you also provide me one of the answers, one of the options? Just select. So Sorendra has given B, and I think I have given ample time. So B is the correct answer. Draw spike is used to remove the pattern from the mold. So okay, Banuranjan, that's fine. Let's discuss what these things are. So let's see what a draw spike looks like, and what this draw spike does. You have just you can just see from the question. So draw spike looks like something like this. So this is your draw spike, or draw screw, you can also name it as draw screw. So what this draw screw does is, this draw screw just lift the pattern from the mold, and we have trowel. So what trowel does, trowel looks like this. So Sorendra has given, I think, every terms here. He has given the correct explanation of the terms. Trowel is used to smoothen the surface. Sovendra has said that swell is used for applying water, and riddle is used to remove the foreign metal. So that is all correct, and let's just see what these things are by drawing their rough diagram quickly. So this is your trowel and it is used for cleaning, smoothing, and patching flat surface of the mold. So that was what Sorendra has also given the answer to smoothing the surface. And next we will see what a riddle does. So what a riddle looks like, let's see first. So riddle looks like this. So this is the wire mesh, and what riddle does is riddle cleans sand by removing foreign materials. So what a foreign material is, foreign material can be wood pieces and nails and things like that. So this it can also be short the short sands and not short sands, short steel, and the things you have used to just clear the casting. And this riddle will just make the sand clear of these things. And the last thing is swab, which I am also drawing at the bottom. So swab looks like this, which is a soft brush. So this is your swab soft brush, and what it does, it moistures the sand around the pattern so that it can provide the strengthen the sand and just prevent the edge from breaking. So these are the things that you should know about the pattern. These are the tools that we use to just make sure that we are doing our casting process properly. And again, the answer to this question is we are removing the pattern from the mold by using draw spike. So I hope every term here is clear. And now we will be moving forward. And our next question here is a cube shaped casting X solidifies in 5 minutes. Solidification time in minute for a cube shaped casting Y of the same material which is 8 times heavier than the casting X. So I hope both the students who are watching this session live, to answer this question you can take 90 seconds. It is fine to take 90 seconds to do this question, but don't make error, take your time. Then I will be doing this question. So again, the second casting is made from the material, made from the same material, but it is 8 times heavier. So how it will affect solidification time, we will have to see. So Benny Jebekson, good afternoon to you. Can you get this answer correctly, Benny? So Benny, Banuranjan and Sorendra, you should take maximum 90 seconds to do this question, and that I am being generous by providing you that much of time to do this question, because again, this is easy question, you will find a lot of difficult question, but if you are taking more time than that, then don't just option A you have given correctly. Banuranjan, have you done the V by A square properly? in the solidification time? Have you done that properly? So if any one of you are taking extra time, then don't just be disappointed in that, because as you move forward you are going to improve your time. That is just a given thing, and also it is better to do a question correctly by taking time than to do it wrongly in a hurry, because that Banuranjan, I think I just by looking at your answer, I just picked the mistake that you have made, and I have pointed it out just a few questions back, that you have to do v by a square. If you are not doing it, you are making a very easy mistake that will going to just hurt you a lot. So B is the answer, and it is correct answer, Banuranjan. And I think Sorendra has left us because he has not given the answer. And Benny, if you are watching it live, you can also just provide the answer. So let's see what is the. So Banuranjan, just make sure that you have written this mistake somewhere in your make a separate copy, or take out a page and write this mistakes you are making, because in the same class you have done this mistake 2 times. So you obviously need to be focusing that you are not you will not make this mistake again. So let's see what we have in this question. Yes, it is always good, because you have to learn from your mistakes. So if you are making mistakes, it is good, but you should learn from them and improve the performance of yours after that. So we have a first cube which is having side A. Let's take it as A or AX, and MX into 8 is equal to MY, because it is given that the Y is 8 times heavier than X, and we can also write it like this. So same material, therefore density will get cancelled, and this is cube, therefore volume will be A cube. So from here we can get that AY is equal to 2AX. So this we can get from here, and now we have to find the solidification time of this Y. So what we will do is, we will first of all write this Tx, solidification time of X. Tsx is K Ax by 6, because V by A for remember this, for a cube V by A is equal to A by 6. So you can do the question a little bit more quickly after you have if you have remembered this V by A ratio, and this is given as 5 minutes, and TSY is K A Y by 6 square, and this will be twice of AX. So we can get we can get 4 K AX by 6 square, and this term right here you can take it as 5 minutes, because it is given as that, and therefore our final answer will be 20 minutes, which is the B option. But if you are not doing this 2 here and not doing this 2 square here, then you are going to get 10, which is obviously given in the option, and you can make that mistake. So now we will move forward and do the next question. Increase in moisture content in the molding sand will lead to. So if you are increasing moisture content in the molding sand, then what will be the result of that? Is the flowability going to increase first, then decrease, or is strength going to continuously increase, or is permeability going to change? So for the students who are watching this class, if you are finding this class engaging and helpful, if you are finding tips and tricks here proper, then please hit the like button there. It helps a lot. And also subscribe to this channel by clicking at the subscription button there and hit the notification icons, so that when I go live or when any educator from this particular channel goes live, you can get a notification. So C is the options provided by Banuranjan and Sobindra. So first increase in permeability, then decrease. So that is obviously the right answer also. So let me just show you another. So I will show you graph. I can also draw this graph, but I think I have this graph already prepared. So let me just show you that. So here are the graphs of permeability variation with percentage of water and flowability variation with percentage of water. And you can see that above 8% the permeability is now decreasing with the percentage of water increasing. So permeability will first increase, and after some time the percentage of water will be such that it will just make the voids take the place of voids, so there will be not proper space left for the gases to escape. Therefore permeability will decrease, and flowability will be increasing after 6%, which is obviously after that the percentage of water will make the molding sand behave more like a fluid. Therefore it will increase its fluid after some time. So these are the variations of flowability and permeability. And will strength will also increase or decrease? Will increase then decrease. So what is strength? Molding sand strength will be with percentage of water. What you can just say, it will first increase because water will make this molding sand stick or just held a little bit more better for some time. Then after that it will increase because of the it will decrease, sorry, not increase, because of the increase in flowability. The molding sand will behave more like fluid, so its strength will decrease then. So that you can also say. So you can also say that for strength. So let's see what the next question here is. Match the following. So you have been provided with four of the terms here, and you have to match this four terms with the bottom four terms. So the four terms are dry sand core, collapsibility of core, core print, green sand core. So you can just provide me the answer by writing the option 1, and if after 1 you are going to match it with C, then write 1C, 2B, 3D, 4A, things like that. And I will be giving this answer in just 30 seconds. I think the time is given to you to solve this question or to answer this question is was ample, and now I'm going to solve the or answer this question. So first of all, 3D, 3D core print seat position to the core. So Sobindra, it is correct. 3 is D. Or let me write it like this. So Banuranjan has also provided the answer, and both of you are providing the same answer. So let's check it out. 1C. So dry sand core will lead to hot tears, and 2, which is collapsibility of core, which will occur when moisture collapsibility of core will occur when moisture is present. You are telling that. And core print 3 is given as D, so core print will be for seed position to core. And green sand core, both of you are providing that green sand core 4 is B. So remember, every time you see the term green, so this term will come, or this term concerns moisture. So this term is there, just select the term which is having moisture in it. So green sand core, which Sobindra, not Sobindra, which Sorindra, sorry for just telling your saying your name wrong there. So Sorindra has provided the answer green sand core for moisture A. So we will have 4A. So again, Banuranjan, I hope you have also understood this thing. If you are seeing green sand, then it will just relate to moisture. And 3D, it is correct. And now we will have collapsibility of core. So collapsibility of core is leading to this hot tear. So it will be C. And 1 will be, that is dry sand core, will be high strength. Let's discuss about this thing. Why collapsibility of core is leading to this hot tears. So what is collapsibility? First, let's discuss this. And obviously it is very important that you remember this detail that I am sharing with you right now, that collapsibility of core should be always ideal. And ideally it should be always having good collapsibility, because if core, why core is used? Core is used to create the internal cavities or the hollow structures. So if the hollow structure, or if the internal cavities that are created by core, and obviously core will be surrounded by this molten metal. So if molten metal, when it contracts, the core will not collapse, then what will happen? There will be cracks generated, which are hot tears. So that cracks will be generated, because when core is not collapsing, it is restricting the contraction. So there will be just due to this restriction, there will be cracks. And which is not, just cracks are always not ideal, not desired. So always remember, for core specially, we must have sufficient collapsibility. So what is hot tears? So hot tears is just some type of crack. So let me show you hot tears. If I have the, so I hope from this you can see what hot tears are. Again, I have done the same mistake. From beginning, I always select that. So hot tears are the defects which occur when there is lack of collapsibility, because collapsibility, again, it is very important, because when there will be contraction, your molding sand should not resist that contraction, and if it is resisting that, then this type of crack will form, which is hot tears. So again, this is a casting defect, more specifically metallurgical defect, and just a type of crack which is formed due to lack of collapsibility. So here is one question that you can see, the hot tearing in a metal casting is due to, and you have to answer this question. Select the answer correctly. C, poor collapsibility of mold. So if poor collapsibility of mold will be there, then you are going to witness this hot tearing in your metal casting. So I hope hot tears are clear to you. So let's move forward and do the next question. So this is the question, numerical question, and here it is asking that molten aluminum was poured in a sand mold and the thickness of the solid skin formed after 20 seconds and 50 seconds were found to be 3 and 4.5 mm respectively. What would be the thickness of the solid skin at the end of 100 seconds after pouring? So again, a nice good variety of question, because we have done the solidification time question. Now we are going to discuss about thickness of solid skin after 100 seconds, and again I expect you to provide this answer. So where was that? So this is the again the question, what will be the answer here? So Banuranjan, should I do this question, solve this question, or are you, or do you know the formula to do this, or the concept to do this, or should I just be continuing with this? And Sorendra, if you are watching still live, and if you can solve this answer, you can just do that, and if you don't know, then we will just start the discussion. So Banuranjan is not, is saying to just continue the discussion. So Banuranjan, if you are having the manufacturing notes with you, if you have attended someone's class, Sorendra is also telling to solve. So to both Banuranjan and Sorendra, if you are attending, if you have already attended a manufacturing class and you have the notes, then you are free to bring that notes in my class and use that note to solve the questions, because ultimately you have to solve the question, and it is better to see your notes and solve the question. But if you are not having notes, then it is also fine, because I am sharing the formula in the class itself. So let's see what we can do here. So to do this question, you have to first of all know how thickness of the solid skin or a casting will vary with the solidification time. So we know from the Chovarinov's solidification time equation. So Ts is proportional to V by A square, and from here you can say that Ts, that is solidification time, is proportional to thickness square, where T is thickness, because V by A we will be left with a single dimension, that will be thickness. So this is thickness, and you can get this relation from this, that thickness is equal to C1 under root Ts plus C2. And I hope how this relation comes you can understand, because Ts is directly proportional to thickness square, therefore we can write it like this after just expanding it. And here C1 and C2 are the constants, and now we know two values of thickness here, 3 and 4.5, and we know two values of solidification time here, and we have to find this C1 and C2. Then we have to find the thickness for 100 seconds. So now Banuranjan and Sorendra, you are free to do this question. You have the required information, you just have to solve this and get the answer. Again, always try to, when you learn a new formula, see a new formula, always try to do the question, because when you are solving this question using this new formula that you have just understood today, then you are going to remember that formula properly, because you have applied it here. So again, you have two T's, two Ts, get C1 and C2 and give me the answer here of this question. So you should be taking, I think 90 seconds should be fine to do this question. There are two equations, and you have this two constants to find. Then you have to find the answer using the last equation. So 90 seconds were given to you. After that, I will be solving this. So I think I should start solving this right now. So what we have here, so Banuranjan has provided us the answer. 6.18 is the answer coming, which is very close to 6.16, which is the correct answer. So Banuranjan, that is the correct answer, 6.16. And I think I uh, will not solve this question now because it is not that hard. It is just involving this calculations, and you can get this answer easily by solving this. 6.192, again Sorendra has also given the correct answer, which is option A, and these are coming in so I will not go through this question, solve this, because it only involves calculation, and you have both done this very correctly. So the correct answer will be 6.16 and again this is from the basic concept that we know that solidification time is proportional to V by A, and if you do V by A, you will be left with this thickness. So this is proportional to T square, which you will expand, then you will get this relation, and you will be getting this 2 constant, and to get this 2 constant you have been provided with this 2 set of datas, and you have to then just after just getting this constant, get the answer by just using this 2 constant and this seconds that are given. So that will be it for this question. Now let's move forward. Permanent mold casting are suitable only for. So again, a nice small question here, but again an important one, because this is giving a very important information about the permanent mold casting. So what will be the answer here? And just guess. If you don't if you are not 100% sure, you can just guess here what you are thinking about this permanent mold casting process. I think C, sir. High volume production. So Manuranjan, are you going to you are also providing C? So Manuranjan and Sorendra has provided the answer C, and that is the correct answer, high volume production. So permanent mold castings are those castings where our mold are not just expendable, it is not destroyed or broken off after our casting process is completed. And permanent mold casting involves die casting, hot chamber die casting, cold chamber die casting, and centrifugal casting is also its type. So in that process, it is very much a trait of permanent mold casting that high volume production is necessary. If you are not doing that for high volume production, then it is not that suitable or economical. So remember this, just remember this little point, that permanent mold casting, high volume production, this is the thing that you have to only remember for your GATE examination. Which of the following statements are true for permanent mold casting? So here you have this multiple choices. Yes, that is also a thing. Metal pattern is used, and when metal pattern is used, we are obviously not going to destroy it, not going to just it is not expendable, that is it is not a it just persists. Therefore we can use it again and again. That is another advantage you can say. So high volume production is the way to just go for permanent mold casting. And if you are wanting some more information here, let me just show you that. So I think that permanent mold casting slide is not with me. There I have a lot of permanent mold casting advantages shown. Let me just check one more time, then we will just move forward. So I don't think that here 8 is missing, and that will be the one that I am looking for. So let's continue our class. So Banuranjan has asked, sir, how many times will you recommend solving previous year GATE questions? So the answer here varies from person to person and varies from question to question. And Sorendra has provided the answer A. And again, Sorendra, here we have a multiple choice option, multiple answer can be correct. So take care of that. So Banuranjan, just solve the GATE previous year paper for at least one time. Then take the questions which you are finding having good concepts or better for revisions, or if you are having made mistakes in some questions, just note it down or just tick them, and only then just do that question again. Don't do questions which are easy again and again, because that will obviously going to waste your time. So what you I would recommend is to go through GATE previous year at least once and take the questions which are having a good concept or in which you are making mistakes, and then go through them once more or twice more till you have till you are sure that you are just prepared this GATE previous year question paper well. And I would also recommend you to go to the GATE's official website, and from there download the previous year GATE question paper from 2016 to 2020, and that full question paper I would just recommend you to just solve it in one sitting or two sittings, so that you can get a better idea what type of GATE question paper questions come in a single paper, and you can also be more confident, and you will be more confident if you are solving full previous year question papers from the official sites. So that are the things that I would recommend, and that will I think benefit you a lot. So that are just my thinking. You are free to do solve like the way you want, or just learn. So the correct answer here is A and C. Sorendra has provided the correct answer. So let's just Benny Jebikson has also provided A, but Benny, here I think you were the one who asked that should sir please give multiple answer questions, and I have given it here, and you have I think provided it wrongly, because C is also correct here. So just I think in that type of questions there will be a statement that multiple options are correct, so you can be just aware of that. And I think I should also write here, so that way that I should mention here before just making you do the questions. So if I haven't mentioned, then apologies for that, but if I have, then you should have answered that. So A and C are the correct answer. They are just permanent mold castings are providing better surface finish from the castings such as sand casting and things like that, and they are having size limitation. And if we simply compare them this permanent mold casting with sand casting, then one of the advantages of sand casting is no size limitation and poor surface finish. So that are the advantages here, and that are the disadvantages of sand casting. Not disadvantages, no side limitation is obviously the advantage, and this is the disadvantage of permanent mold casting. But the correct answer here is A and C. So complex shape can be produced in permanent mold casting, but it can also be produced in expandable mold casting or non-permanent mold casting if the non-permanent mold casting is investment casting. So investment casting is non-permanent mold casting, and there we are also getting complex structures and good surface finish. So you can tell that for permanent mold casting, but it is also true for some of the expandable mold castings. But for sand casting it is not true, so just take care of that. Which of the following metal component can be preferably cast using hot chamber die casting process? So Shreyas has joined the class. So good afternoon to you, Shreyas. And we are discussing here casting. So if you can provide the answer here, which of the following metal component can preferably be cast using hot chamber die casting? To the students who are watching this session live, just go with one answer. Zinc, Banuranjan, you are giving the answer zinc, and Sorendra. So again one of the students has joined. So again Banuranjan here has given the answer zinc, and Sorendra here has given the answer cast iron. Not sure. So Banuranjan, you have provided the absolutely correct answer zinc, and to Sorendra, you have to remember for hot chamber die casting that low melting point materials, metals like lead, tin, and zinc are cast using this process. So this is very important thing to remember, because this is having a high chance of getting asked in GATE examination or some other examination, because this is very common and popular question. So remember this three materials, and these three are having this common trait or characteristic that they are low melting point, and therefore hot chamber die casting is used to cast this three types of material, or three not types of, three materials casting: lead, tin, and zinc. So just remember these three things. So I have also taken casting classes, but I have taken at just a while ago, so you can always see that. But right now, if you are preparing for GATE examination and competitive examination, I would just recommend you to do questions and learn from them. But if you are preparing for university examination, you can always watch the casting class when you are going to you can watch this by just visiting the website. There a playlist will be there with my name, you can attend that. But for the competitive examination like GATE and some other examination, ISRO, BARC, ESE, it is better that I am providing you these questions, and through these questions you are learning. So I think this will make you learn a lot in less possible time. Yes, on this channel it is there, but this channel will mainly be focused for questions. But when I joined this channel, I have already prepared that casting material, so I just taught it with using that material. So in continuous casting process, the mold is generally made up of. So again, you have to know this answer, and Banuranjan has provided us the correct answer, which is copper. And if you are not knowing the correct answer, then you cannot solve this because it is from the theory. Continuous casting process are generally used to produce long objects, and copper is the mold material there, so that will be the answer. So just remember copper here, because again this is from theory. There is nothing to understand here. It is just asking that in continuous casting what is the mold material made up of. It is copper. Here is our next question, which is a numerical question, and I expect you all to do this question because this question is not that difficult, but it is having a simple logic which can get asked in gate examination, or if you are seeing this for your university also, there can also be asked, because this is from the basic concept. So I will give you 60 seconds to do this question. That will be ample amount of time. And again, I would just like to point it out here that if you are watching this class live, then just hit the like button if you are just finding this class helpful and engaging, and just subscribe to this channel so that you can get the live classes of mine whenever I goes live, and hit the bell icon to get notified. And I will be taking today's class at unacademy.com 8 p.m. today. Only 1 hour class will be happening of today. So if you are having if you are free that time, you can attend the class. We will be discussing important questions there also, and there you can also see what Unacademy's just interface is. Just be familiar with it, and to just attend the class, I think you will need this code SPABHIMI. If you are using this code, then you can attend the class free there, my class free there. And what will be the link of my class? Let me just provide you that also. So here is the link of my class. So again, this was the question that I told you to do. So what this question is asking, the flow rate of liquid metal in the down sprue of a mold. So flow rate is given, and Banuranjan and Sorendra, I hope you are going to provide me the correct answer of this. Q is given 1 liter per second, which will be 10 to the power minus 3 meter cube per second. Cross sectional area of the 426.4. So I think the answer key of mine is saying 430.74. So 430.74 is the correct answer that you should be getting here. And if you are getting that much of variation, that much of variation can just make your answer wrong. Just you can just see where you are doing error. So this is the correct answer from the answer key. So cross sectional area at the top of sprue is let's write A2 there, and length of sprue is 275. So is anybody of you getting 430.74 exactly? So Banuranjan and Surendra, are you getting this answer 430.74 exactly, or just 430, around 430? So that will be good to go. So you have been provided with this so you have your pouring basin, and you are provided with this area at the top of sprue, which is 2, and here let's say it as 3, and it is at 1. This is your pouring basin. So Surendra is getting 4.3, so that should come well within range, so that is correct. Pouring basin, and 2 area is 800 in mm square, and 3 we have to find the area 3, and we have also been provided with this length of sprue, which is 275 mm. So to calculate area 3, what we need to do, we have to make this Q, volumetric flow rate, equal to area 3 and velocity at 3, and velocity at 3 will be under root of 2g ht, that is total height. So Banuranjan has also got 430. The total height should be the height of this sprue plus the height of pouring basin. And to calculate height of pouring basin, we have to first calculate the velocity at 2, that is the top of the sprue. And after we have just gotten this velocity at the top of the sprue, then we can get the height of the pouring basin. From there we can add that value to the sprue height, and after that we can just get the answer. So what is the height of sprue coming? Can you share with me the answer? What is the height of sprue pouring basin coming? So I think I will do the question calculation here only. So let's see. Let us do that in other slide here. So Surendra, why have you taken G10? It is not given in the question. So don't do such things. That will obviously make your questions wrong. Always take 9.81 by default, and only take G10 when it is given in the question, because that can change a lot your answer and make your correct approach wrong, and that will just going to hurt you a lot, because you have done all thing correctly, but by just assuming one thing you have made this error. So let me just calculate it, this. So we have this q is equal to this 1 liter. So 1 liter will be 10 to the power minus 3 meter cube per second. So this will be 10 to the power 6 square. Here it will be second. And we have this area at 2, velocity at 2. So velocity at 2, we need to find this height of pouring basin. Let's write this as HP. So area of pouring basin is given as 800, not pouring basin, area of, not pouring basin, top of the sprue is given at 800, and area of top sprue we will just write it here, and what then this velocity at 2 will come out. It will be coming out as 1250 under root 2g HP. Then what will be the HP here? So I think HP is coming out as 79.64 in mm. And let's see what is the other thing here given. So length of sprue is given as 275. So total length will be 79.64 plus 275. It will be 354.64 mm. And then we can find V3, which will be in we will be finding this in mm. So what we will do is we will do this 2 into 9810. This is in mm per second square, and then we will do this HT multiplication there. So what we will find? We will find the velocity as 2637.80 mm per second. And then we will just use this equation, this 10 to the power 6 mm. Here I have written square, it should be cube. So very poor mistake there. So it will be area at 3 into velocity at 3. So what will be the area of 3, area at 3 here? It will be, so I think it is coming out a little bit wrong. I have I done something wrong here? Let me just check it out. So my answer is coming out as 379, which is obviously not the correct answer. And I think I have done some calculation mistakes here. See, the basic concept should be clear. Q is used to follow, just calculate the pouring basin height, which is coming out to be 79.64. And I think here is the error that is made. Is pouring basin height coming out something different? Is it coming out different than 79.464? So Banuranjan is saying same only, and Surendra, you have gotten the correct answer. So were your also HP pouring basin height coming out similar 79.64, or was it coming out different? So Surendra, if you are watching, you can share the value of HP, that is pouring basing height, if you have found it different than ours. So I think I have yes, I think also that will be the correct answer here. And the answer key I have written, it should be wrong, but somehow, yes, I also checked it, and somehow Sorendra has gotten the correct answer. So I think there might be something we are missing here. So let me just check for one last time, then we will move forward. And if I find something worth mentioning in this question, then I will share it with you in the next class. So I think I have got the correct answer for 430.5 here. Uh, and what they have done is, let me just tell you what they have done. Let me just tell you here only. So what this answer key seems to be doing is, they have taken the velocity at 3 by simply putting 2g hs. 275 they have put here in mm. So the velocity at 3 is coming out, if we follow their this 275 approach, it is coming out as 2322.82 mm per second. And then what they have done, they have just calculated using this velocity, and then the answer of area is coming out as 430.5 mm square. So Banuranjan, can you see what is the approach done to get the answer 430.5? And I don't think that is the correct approach, because here the sprue length is given as 275, but when we calculate velocity at 3, we find the uh, no, this is not correct. What I am telling here is that whenever we find velocity at 3, we take the total height that is there in your notes, that is there in your theory. We always do that, and that is logical also, because that is from the Bernoulli's equation. So we have to just calculate first of all the sprue height, and if it is given, then it is good. Then we have to calculate the pouring basing height and add that, and after that we can just get the answer. Let me just check one more time, is this question is giving any assumption that we have to neglect pouring basing height? So I think no assumption is given here, only sprue length is given. So the correct answer will be this one, 379.10. This should be the correct answer. So Banuranjan, you can give, at least I think you should give 6 or more than that if you can find, because and start giving the gate preparation, gate examination test, the test series, as soon as possible. Don't wait for any more time, because after you have given a 3-hour test or a 1.5-hour test also, you will have to analyze your performance, and therefore you will be wanting to just make sure that you are giving the test from as soon as possible, so you have ample time to also learn from the test series as much as you can, and also to revise your previous what you have studied from your theories. So to do revision and to do test series, you have to start the test series as soon as you possible. So yes, I used to also score around 50s and 40s at the start, then I improved and that I just start scoring around 70s. So what you can be doing here is that you can be just don't get disappointed with the score. Try to learn what how you can just what your mistakes are, try to just improve them. And one more important thing is how you approach doing questions, and you have to find the best possible approach according to your uh, way of giving the exams. So if you are going to solve aptitude first, you are free to do that, but you can also do that at the last or at the middle. So that proper time management can only be just get to know when you are giving a test series. So try to give test series and try to analyze your mistakes, and then when the next exam comes, at least try to not make the same mistakes that you have made in the previous test series. And if you are making mistakes by not solving, by just forgetting the formulas, then try to remember the formulas. So overall, try to improve your performance to 60s at least. I think in your test series 60 score should be fine, because test series are usually harder than your final gate examination, because in gate a lot of trickier question comes which are easy if you have right concepts. So try to score at least 60 for a change, and just try to analyze your performance, that is must. So don't get disappointed. So you can yes, you can do that both test series also, that will be fine. And just try to score as much as possible. Try to give the test series by just thinking that you have to score there. So don't waste your time in a question which you are not getting right answer. And because every question is equally important, because they are giving you either 1 marks or 2 marks. So if a question is easy, just see that question and make sure that you have given right answer, not made the silly mistakes in a hurry, because that is one of the things that a lot of student does. And in this class only, Manuranjan, you have made a common mistake of not squaring v by a ratio. So try to not make mistakes like that. And if you are having difficulty in avoiding these mistakes, what you can do is you can prepare a new copy where you are only writing the mistakes that you are making in the test series, and then just review them just before giving a test series, so that you can at least not make that test that errors in your test. So these are the little things that you can do to avoid all. And always just make sure that you are reading a question properly, not in a hurry. And always try to check the units, because units are also there where a potential error can be made. And just be calm, because a lot of questions in the gate are trickier but easy. So if you are solving it, reading the question with a calm mind, then you can do the job there. So here you can follow me, visit the Unacademy's website, the link here. Just note it down in your copy and visit there and follow me. And just you can download the Unacademy app. So that is not needed. I think I have not during my time of preparation, I have not never given 30 full length test series for a single gate exam preparation. So that is not the, I think you don't focus on that. Focus on just giving test series in a week. Just give 2 test series, that will be fine. Start from today and just give 2 test series in a week, or after 4 days. Just make a habit of giving that, so that you can be just stayed you can be just having a familiarity of giving test. And try to take each test series mistakes and learnings properly. Try to just analyze them properly, don't just move forward. So follow this approach. I think this will be more beneficial than just setting a goal that you have to solve 30 set test series or 20. Just do a test series in every 4 days or so, 4 or 5 days, and just analyze it thoroughly. And also you can just do previous year GATE question paper by downloading it fully from the GATE's official website. So you can also get to know what type of questions GATE ask in and how they are asking it. So that will be more beneficial to you also if you are doing that. So I think we have this few questions left for the day. So let's do them. Then we will end this class. So we have this one question and two theoretical questions. So I think this should take 10 minutes or so to complete the class. So a certain mold has a sprue whose length is 20 centimeter and the cross-sectional area at the base is 2.5 centimeter square, and sprue feeds runner leading into a mold cavity whose length, not length, volume is this much. Time required to fill the mold. So we have to find the time required to fill the mold, TF, filling time. And these are the informations that are provided to us. And to Sorendra, if you have left the class, then I would just like to inform you that your answer was wrong. My answer key was wrong because there we have to consider the pouring basing height also. So just take care of that. We calculated it correctly. So if you are remembering this filling time formula correctly, then it is fine. If you are not remembering it, just open your copy quickly and just see what the formula is and then give me the answer. Then after this class will end, just learn that formula. So I think this much of time, 3.2 seconds is the answer provided here by Banuranjan. So if this answer is correct or not, let's see. So TF will be, for here we will use this formula, volume of cavity casting or mold cavity divided by area of gate under root 2g ht. So the values here given are in centimeters, so we have to just be aware of this fact. And area at the base of sprue is 2.5, which will be similar to area of gate because that is not given, so we will assume it like that. And under root 2, 9.81 will become 981 in centimeter per second square, and ht will become simply 20 because we have no other means of calculating pouring basing height, so we will just roll on with this. So here our answer is coming out as, it is coming out first of all in seconds, so it is coming out 3.15 seconds. So that is B, that will be the correct answer. Now when you are selecting the correct answer, just take care, remember that there are different units for same value. So don't just see the units, don't just see the numerical value, see the units also, because here it is given to confuse you, to make you select wrongly either by mistake or either after confusing you. So just select the answer that is correct by reading the whole option. So again I should just B is correct. Select the correct option which are employed in shell molding. So for shell molding, which of the following things are employed? So Banuranjan, here again I should just point it out, it is multiple answer correct. Multiple options can be correct here. So among this resin binder, metal pattern and heating coils, which are employed in shell molding? So the correct answer to this question will be all three. In shell molding, we are creating shells, and from that shell, yes, A, B, C are correct. That is the correct answer. So in shell molding, we are creating shells, and from that shell, we are creating mold cavity. And resin binder is used to make the sand mold stick better with the metal pattern, which is heated by using heating coil, which is heated because at that high temperature resin binders binding property will be better. So we are heating the metal pattern, and then we are just sticking the or making the molding sand stick to it, so that we are left with the shells which we are using to create mold cavities. So therefore the 3 ABC will be correct. So correct answer is that. Now let's do the last question of the day. Which of the following defects matches with the property shown in the right side? So hot tears, porosity, sand inclusion, shrinkage cavity. Again, this is the final question of the day. You have to again provide the answer similarly. Just write the one, and whichever answer is correct to it, just write it there. So what will be the answer here, Banuranjan? So I will give you 30 more seconds. After that, I am going to just answer this. So 1D and 2A, 3B, 4C. So you are telling 1 is D, that is 1 is residual stress. 2 is A, porosity is poor permeability, it should be clear. 3 is B, sand inclusions, loosely rammed sand mold, and shrinkage cavity is due to inadequate rising. So shrinkage cavity will be mainly liquid, and will be not mainly, will be liquid shrinkage and solidification shrinkage, which should be compensated by rising. So riser. So if riser is not provided properly, then not does it job properly, then there will be shrinkage cavity. Sand inclusions will be when loosely rammed sand mold will be there, so dimensional stability will not be there, and therefore inclusions can occur in your casting. Porosity will occur when there is poor permeability, that is we have to do venting properly to avoid this poor permeability, and therefore avoid porosity. Hot tears are occurring due to residual stresses, which again is reason due to your poor collapsibility. So I think you are so Banuranjan has provided the answer correctly. It is 1D, 2A, and 3B, and 4C. So that will be it for today's class. And if you found this class helpful, you can just hit the like button. Just use this code if you want to just get an Unacademy subscription, and also subscribe to this channel from this video itself, so that you can get notified whenever an educators come live. And also this is the my Unacademy link where you should follow me, and there you can attend the class by using this code, that is SP for special classes, ABHIMI for Abhishek Mishra. So SPABHIMI is the code that you can use to just attend free classes there. And I will be going live today 8 p.m. just to take an hour of class. So an hour of class we will be taking there. So see you there then. If you are just free, you can attend then. And that will be it for today's class. Best of luck for your preparation. Thank you for watching. Stay safe and take care. That's it for today's class. So Banuranjan, which topic, sir? So I think today's topic is, I am going to just discuss about the most likely questions from the manufacturing subjects also. So we will be just doing nice amount of questions there from all the topics. And after that, I have also planned to cover in a few days complete revision of certain topics like casting. We will be revising important formulas and things like that of metrology after that. So just you can attend this class and find some nice questions which I will be explaining properly and which I think are most likely to come in your GATE examinations. So that's it for today's class. Again, thank you for watching. So stay safe and take care.